In this video 5.8, we're going to be graphing absolute value functions. By the end of the video and work time in class, you should be able to say, I can graph absolute functions. An absolute value function has a V shape. Look to it. It's a graph that opens up or down. The parent function is y equals the absolute value of x. A translation is when you have a shift of a graph, either horizontally, vertically, or both, and you're going to see that you're going to be essentially taking the parent function and translating it in this lesson. The result is a graph of the same size and shape, but you're just changing the position. It's just a different position, either right, left, up, or down. And we're going to make two graphs here for this problem. In the first graph, we're going to graph y equals the absolute value of x, and then we're going to graph y equals the absolute value of x plus 2, and we're going to see what happens, what type of translation in particular. So in the first graph here, when you put in 1 for x, the absolute value of 1 is 1, absolute value of 2 is 2, absolute value of 3 is 3, absolute value of 4 is 4, 5 is 5, 6, 6, and so on. Absolute value of 0 is 0. Absolute value of negative 1 is 1. Absolute value of negative 2 is 2. Absolute value of negative 3 is 3. So we can put anything in for x, and then we get our y. We see here this is our parent function of our absolute value functions. You can see that V shape. Now we're going to look at y equals the absolute value of x plus 2. So when we put in 0, absolute value of 0 is 0, plus 2 is 2. Absolute value of 1 plus 2 would be 3. Oh, let me erase that first one there. It's got to go up 2. There we go. Absolute value of 2 plus 2 is 4. Absolute value of 3 plus 2 is 5. Absolute value of negative 1, which is 1 plus 2, gives you 3. Absolute value of negative 2 is 2. Plus 2 is 4. Absolute value of negative 3 plus the 2 gives you the 5. And here you can see this is our V-shaped image again. So how are these graphs related? The y equals the absolute value of x plus 2 is y equals the absolute value of x shifted up 2. So we're just moving it up 2 by adding 2. Now notice though when you're adding 2, it's on the outside of the absolute value symbols. Now let's graph the absolute value of x minus 3. So put in 0, you get 0 minus 3 is negative 3. Absolute value of 1, 1 minus 3 is negative 2. Absolute value of 2, 2 minus 3 is negative 1. Absolute value of 3 minus 3 gives you 0. Absolute value of 4, which is 4 minus 3 is 1. Now I'm going negative. Absolute value of negative 1, 1. Minus 3 is negative 2. Absolute value of negative 2 is 2. Minus 3 is negative 1. Absolute value of negative 3 is 3. Minus 3 is 0. We can see it's the parent function. However, now take that parent function and slide it down 3. So you can see by adding or subtracting on the outside of the absolute value symbol, you're moving it up or down. So what is an equation for each translation of y equals the absolute value of x? If you're going 7 units up, that would be y equals the absolute value of x plus 7. If you are going 5 units down, it would be y equals the absolute value of x minus 5. But now in this next problem, you can see I put a minus 3, but I put it inside the parentheses. So let's pick some x values. Let's just start with 0. When we put 0 in for x, 0 minus 3 is negative 3, and the absolute value of negative 3 is 3. So 0, 3. And if we want, we can make a list of ordered pairs if you want to see them. But you put in 0, you get the absolute value of negative 3, which is 3. So 0, 3. Now I'm going to put in 1. 1 minus 3 gives me negative 2. Absolute value of negative 2 is 2. So 1, 2, plot that point. Put in 2. 2 minus 3 is negative 1. Absolute value of negative 1 is 1. Put in 3. 3 minus 3 is 0. Absolute value of 0 is 0. So we're thinking, where is that v? Now let's put in 4. 4 minus 3 is 1. Absolute value of 1 is 1. So 4, 1. Now we're starting to maybe see what this v is going to look like. Put in 5. 5 minus 3 is 2. Absolute value of 2 is 2. Put in 6. 6 minus 3 is 3. Absolute value of 3 is 3. So now you can see the v shape here. So by subtracting 3 on the inside of the absolute value, it moved it to the right 3. So now it's the parent function, but you moved it to the right 3. Now notice in the beginning when we were plotting those points, we were just seeing a line. We weren't seeing the v yet. You know if you have absolute value, you're going to see a v. So if you don't see the v yet, you got to keep graphing until you do see that v-shaped graph. So if you're subtracting on the inside of the absolute value symbol, that means you're going to the right. So if you're adding, you're going to be moving to the left. So if you have 4 units to the right, it's going to be y equals the absolute value on the inside. It's going to be x minus 4, means to the right. So it's like the opposite. If you're subtracting on the inside, you're moving to the right. If you're adding on the inside, you're moving to the left. So 6 units left would be y equals x plus 6. And that would move, like I said, to the left 6. And just on a side note, if you were going to take and graph the opposite of the absolute value of x, it would be a v, but it's upside down when you were to graph that. Can you say I can graph absolute value equations and functions? Write a summary and reflection and be prepared for the work time in class.